I have prepared a PDF for a sheet metal component that you are seeing in front of you. It has 2 pages and we are going to model this sheet metal component together as an exercise. I want you to go ahead, either take a screenshot. You can do that by holding Window key, Shift key and the S key and dragging a window, and take a screenshot of the first page and the second page. Okay, I'm gonna start with this one over here, with this view. And my commentary will be reduced when I'm working with SolidWorks because my cache cannot handle. I'm just trying a couple of stuff to mirror them and using trim entities to get rid of them. And now I have the value 140 here. So which would be this one, 170.40. This value over here is this one, 200.78. By the way, the tolerance and the sheet metal thickness and the sheet metal radius are defined here. Tolerance 0, plus minus 200 microns, and thickness 3, bend radius 5. Now I'm going to do this bit, this area over here. Okay, now the dimensions for it are on the first page here on this detail view, 5166. 6578 and 7118. Going back to here, 110.76. We have, going back up here, we have 20 degrees for this one. We have here to here 2564, and we have the next one is 5026. 5026. Okay, let's add the radiuses. We have 6 of them. 1, 2, 3, 4, 5, 6. So that's okay. And we have over here 4 radius with a radius of 4. 1, 2. That's right, it doesn't have any flat line. So I'm gonna do curve to line and 3, 4, done. And I can get rid of this line and this line. This value, this line here is 4.12. And let's see why it's not fully defined. Oh, that's the height. Okay, so for the height, I go here and I see a value here, 20.53, which is here to here. 20.53, and the total height from here to here is 67.20, and it's fully defined. All right, so I'm gonna go ahead and find sheet metal tab, base flange, thickness 3, that's fine, and click OK. Let me just, 2 radiuses are missing here. Let me just edit my sketch. Radius of 5, I believe. Oh, the last 2 I assigned it to the out ones. They were actually the last 5 and 6. I believe so. So it's still okay. So this is my sheet metal component. I have a sheet metal folder here. Sheet metal. If I right click here and edit the feature, I can see the thickness is 3, but the bend radius is 30. We don't want that. Just do 5 and continue doing these flanges over here. These over here with 170 degrees angle between them. So 2 flanges, 170, it means each with a value of 10. We're gonna go to edge flange, like this. Right now they're at 90. So I'm gonna change that to 170 or 10 and reverse that like this. So 10, bend radius 5. Now the length of that is 6230. Let's do this, 6230, and click OK. Now from here, we go up again. We have another flange. You can see it here on the isometric view. So we go down and we go up. And the ones that are going up are vertically up. So the bend is not 90 degrees, because if I do 90, the line would go here. It's another 10 degrees, which you can see here, 80 degrees, 10 here and 10 there. So we do 100 degrees. Edge flange, one more time. We go up for both sides and we do 100 to go vertically up. And how much we go up is shown here, 37.12. Let me just do that. Let's zoom it in here. 3712, but not just from anywhere. from the very bottom over here. And I have the options to change all of that, so it depends. Let me just go with this one, and the back should be aligned here because we have already assigned the 60 to 30. So the back should be here, here. Click OK. Now let me just see how much of distance we have. 3712 from the bottom. That's probably right, but I want to be sure. If I draw a line horizontal here, have it tangential, and then measure the distance, 3559. Okay, so we are 2.5 millimeters short. No. 1.5. I'm sorry, half of a thickness of the sheet. So let me just do this. I could do that. Oh, sorry, not this one. Here, this one, and go in. Let me just measure it again. One line right here, tangential. 3916 instead of 37. So we are 2 millimeters too much. 3712. This is it. I believe now we are on the right spot. 3712. This is it, okay? It's important to check. And let's just check one more time. The measure. I'm going to use the measure tool that you find inside the evaluate tab. Measure from this line to this vertical line over here should be 6230. We have 6304. So we are not quite there yet. 6230, it means 1.74 too much. Almost half of wall thickness again. And this means this one. 6230. Half of wall thickness, and this is with an offset, not this much. So I'm going to have it on the inside, just minus 1.74, I believe. One more time, measure it from this line to this line, 6130. Now 1 millimeter too short. Oh, it was just 0.74, not 1.74. This line to this line, 6231. I'll take it, okay? Because the tolerance that I have on the sheet is 200 microns, and this means 10 microns. So I'm still within the tolerance. That's number one. Number two is this flaps, these flanges on this side, and I need to add a tab. As you can see here, there are some extensions extending out of this. So let me just do that. And there will be a correction in the value, which I will tell you. So we want to do that one, draw a rectangle. Roughly like this. Then I'm going to place this point on this line, make coincident like that. Now, go up on this view. The total length is 11601. 11601. And the offset is from this side, not from the side that it extends out. Exactly, from that side where we have this pointy thing, 20.53. So it means from this line to this line is 20.53. Now the depth of this is 28. I believe I need to fix this value, but first let me find where it is. Oh, it's here. Goes up 29.25. This is the one I want you to fix. This is 28. Okay, this is 28. So we give this one 28. Then we just go to the sheet metal tab, do a normal base flange with the same thickness, and it adds to the design tree as a tab, which is okay. Now we're not just done. We need to add this slot over here. So draw a new sketch, slot vertically down, and add the dimensions. 6.486 from here to here, 8.22, and from here to here, by holding the shift, I could achieve this dimension, 5.26. Now I can just go to the normal feature tab and do a normal extrude cut. Done. But I'm not finished. I need to do this flange over here too. You can see it. We go to sheet metal tab, edge flange. Now this time from this side. And as you can see, we have already assigned the 11601 to the total length. So make sure your flange is not going out. You're not looking at this, okay? We need to be looking at this. Also for this end too. Oh, that end, we're going to mirror this. For how much? So let me just find the value for over here. We have it 29. 29. This value. 29, okay. Now let me just try to mirror. The fact that I have my right plane cutting my component in half is because I placed the very first rectangle and made its center point on the origin. Okay, looked unnecessary, but right now it's very useful. So we go to feature tab, mirror. It's a feature that I want to mirror, this one and this one. So since it's picking the wrong one, I'm going to open the tree and select these three. Done. Okay, now the radius over here is 5. The fillet on its sharp end, on the sharp edges, where was it? Over here. The bend radius is 5. I go to sheet metal, go to corners, break corner, trim corner, pick fillet, not chamfer, and then do this for all these lines or edges like that. Okay, we're still not done. We have 2 holes over here, radius or diameter 5. So new sketch, circle, center line, select them, mirror them, diameter 5, height 1446 from this top edge, and distance 1031 from here, 1031. Now I can just do a normal cut and ready. This bit is missing, this area. We need to do that one. So let's just figure that out. We need another flange over here and we need to edit this one. So we go up, but look, it's not going up exactly. It's coming out and then going out. It's coming out for 23. So let's make sure we are looking at the right angle first. So this line is aligned with the back. We are not looking at, I don't know, this. We are looking at this. This one, it gives me the offset version. So I'm gonna do an offset of 23 like this. And how much does it go up? The height. First of all, it's 140. The width is 140. I need to adjust it here. And it goes up 54.78, but it goes from this line over here, not from here, from here. So how do I do that? Instead of just defining its value over here or doing calculations, I will just click on edit flange profile. I cannot assign a dimension here. As you can see, it gives me an error. To do that, I need to drag this a little bit and this one a little bit, and then I can adjust it. So 140. And the center point, right click, midpoint, should be in a vertical relation with this one. Now the height from this line, hold shift to this curve on the bottom, we are 54.78. And then I can click OK. I don't see OK because my PDF is covering that. Finish. So we have that. And now we do this cut at the end. 90 degrees with a value of 28.57. So 28.57, let's just go to corners. Break. This time we do chamfer. 28.57. It's already at 90 degrees. Boom and boom. Okay. Now every radius that I have here is already filleted with a radius of 5. So I'm just going to select those. Not every, just select the ones I'm selecting. 1, 2, 3. Let me see what else is missing. I think everything else is fine. Now we have 3 holes here. It's rather easy. 3 circles. There are some issues with my new SolidWorks. I'm going to select them, make them equal, a center line to the center of this one, make this one vertical, select this one, hold the control key, select symmetric. Radius or diameter is 3, as you can see here. Distance between them is 35.5, and the height is 20.35, as you can see here from this edge, 20.35, and they are not in a vertical or horizontal relation. So I'm going to select them all and then have them in a horizontal relationship, extrude, and okay. Still some stuff missing. These 4 rectangles and 2 holes, which I just do here. Quickly, 4 rectangles. The faster way would be to select them all, have them equal. No, there are 4 equal rectangles. A center line vertically up for symmetry, and this point line and this point symmetrical. This line and this line in a collinear relationship. This line and this line the same. This line and this line the same, as well as this line and this line the same. Now if I move one of them, all of them will move. So the dimensions are 16 by 16. You can see it here. So when I do 16, all 4 are 16 by 16. The height from the top is 20.53. So this line to this line is 20.53. The bottom of this one to here is 15.70. So from here to here, 15.7. What else? The distance from this side to the back is 8709. From here to here, 8709, and it's fully defined. Now 2 circles, one here. Select these, not that, these, mirror, Diameter is 8.18. Distance is 74.33. The height from here to here is 1161. From here to here, 1161. Now we just do a normal cut. Boom. Okay. And this would be it. We do one last check because we want to check the weight of the material, and I want you to make sure that you have done it correctly, just like me, and you get the same mass value. So 324.01 here. 325.39, 324. So something is off. How much? 325.39 minus 324.01, 1.38 is off. Double check. From here to here, we have the 62.31, 62.31. That's okay. What else? From here to here, we have 199.38. This is it. This is exactly the difference. See? So instead of 278, I get 138 less. So why do I have this issue? I know why. Because I changed this one, and I brought it in. This is the issue. Instead of having it like that, I have it like that. So if I move it out, then I'm just extending that 62.31. So I'm gonna reduce it here. Let's just do 60 and measure again. First thing first, let me just measure the total length of the component from this surface to this surface. 322. Was I not 324? It should be 62.30. 62.30. Total length, this surface to this surface. 326.87. Now we are above 325. Okay, 1.5 above that. So how do I do this? That's 1.5 above it. So we do 61. But if I do this, 324.31 plus 75, which is half of 1.5. Then from this surface to this surface, 325.78, still 0.39 too much, minus 0.39 divided by 2. Now from this surface to this surface, I get 325.4, which is 325.39. Okay, how about this surface to this line? You might have, oh, 62.31 is now correct. 62.30. I'll take it. And let's just do one more measurement, a couple of more measurements. This should be 140. It is. This should be from here to here, 116.01, 116.12. Why? Why? Okay, I take it within the tolerance. So let's just bring back the PDF to a little bit full screen. Material is stainless steel ferritic. Don't forget to assign it. Right click, stainless steel ferritic. Now the mass value is 734.41 grams. Now let me just go ahead and order this component. This is your value. To do this, I'm gonna go to comacut.com, get instant quote. All right, upload 3D files. I'm gonna save it as comacut Aryan. Let me see if they can actually read SolidWorks native format. They cannot read the convert to mesh. So let me just help them a little bit by saving my component as step and then retry. Okay, done. Material, we can do stainless steel, series, okay. Thickness 3, finish, mill finish, tolerances, standard. What is the standard? Standard is 0.45. No, I have to go high precision. Quantity 1, number of threads, I don't have it. Calculate this. That would be really fast. I did one video for them before. This is not sponsored, but in that video, I put even a special link for you that kind of included a discount. You can go and watch that video and find a link. This is really good. You know, the fact that you can just upload here, upload your component and get a value for it. Like one piece is $82. Okay. And I have already done that. This is a component. Rather heavy. The surface finish, you can see it perfect. It used to be this. So this is the flat pattern, as you can see. And after bending it according to my bend table, I get this component. If you would like to hold it in your hands, the first person who comments, I want this, I will be shipping this to you. But keep that in mind. Knowing how to work with sheet metals could be your edge in shining in your resume. Designing a mug, an airplane, something like that, it looks good, it's necessary, it polishes your skills. I do a lot of those trainings in my course, SolidWorks Course Pro 2. However, you need to learn some DFM, design for manufacturing, and sheet metal is one of them. Knowing how to create a component that is from a sheet metal puts you on the top. Why? Because it's the cheapest manufacturing method out there. One day I was walking on the street and I saw countless number of examples of sheet metal everywhere. And I bet if you open your eyes to it, you start to see them everywhere, on your desk, in your closet, on your phone, in your car, on the street, wherever you look, you see some sheet metal components. If you want to use ComaCut, this is the fastest way to get some quotation, to do some calculations for your project. This is your cost calculation, very easy. So let's say instead of one, I want 1,000 components. Oh, look how fast it adjusts live. So one component is $80, 10 is 22, 100 is 14, 1,000 is 11, 10,000 is 10, 100,000 is 8. So above that, it just stays on 8. Okay. If you get higher and if you're designing something for batch production, sheet metal is this. Look, $8, something so big. Now try to do that from a CNC machine and then bend it. Good luck with that. It's not going to be $8. Okay, if this video was helpful for you, I cover the basics of sheet metal for beginners in the video on the right. So go ahead and watch that. It will be very helpful. The watch now symbol you see on the middle of the screen takes you to my webinar. Go ahead, use it. It's free. I recommend you to watch it. And the video on the left covers a technique that allows you to print large components on a tiny 3D printer. 3D printing is also another DFM. So I want you to add DFM to your resume. Thank you very much. Don't forget to subscribe.